All right, so for today's video, we're going to look at yesterday's notes. We're just going to wrap those up with elimination. So we did like by graphing and substitution yesterday. So when we have two equations, right, and they're not linear, we can still use elimination as if it was linear to solve it. Notice with this one, right, this is definitely a circle. X squared plus y squared is 10. This is a little different. I have a coefficient in front of the x, and it's not the same coefficient in front of the y, which means I couldn't divide both of these by 4 and get the same, one leading coefficient. It's actually not a circle. We're going to find out what it is in a second. But regardless, we can still do this with elimination. So I see that on both of these, I have y squared, and I don't have to rearrange these. I have my constants to the right. I have my y squareds lined up, my x squareds lined up. So I'm just going to subtract these two equations. And when I subtract these two equations, I will simply eliminate the variable of y. Right, so 4x squared minus x squared is 3x squared. And then y squared minus y squared is just 0, so it's eliminated, equals 13 minus 10, which is 3. I can divide both sides by 3, and I'll get x squared equals 1. And then obviously I'm going to take the square root, plus and minus. And so x will equal plus and minus the square root of 1, which is just plus and minus 1. So now that I have two different x values, right? So when I plug in my two x values, I'll try positive 1 first. And again, just plug it into one of the two equations. It doesn't really matter. The bottom one looks a little easier. So I'm going to do 1 squared. Whoops. Well, I'll do negative 1 first since I wrote it. Negative 1 squared plus y squared equals 10. And then basically negative 1 squared is 1. So I'm going to get y squared equals 10 minus 1 after I subtract it, so 9. And I'll get y equals plus and minus 3. So I want to write down those coordinates. I plugged in negative 1 for the x. So it's negative 1, and then I got positive 3. But I also plugged in negative 1 and got negative 3. So those are two coordinates right there. And I haven't even plugged in positive 1 yet. Remember, all I did was plug in negative 1. So if I plug in positive 1, positive 1 squared plus y squared equals 10, I'm going to get the same thing. I'm going to get y squared equals, I'm going to get y equals plus and minus 3, right? Because 1 squared is going to give me the same thing as negative 1 squared. I'm going to get the same results. But that basically means I have 4 different coordinates, because this time I plugged in 1, and I also got positive 3 and negative 3. So I have 4 different points. Those are all 4 of my answers. So in case you're wondering what that could possibly look like, I did it all right there. You can graph it on Desmos or your graphing calculator. But these are our 4 points of intersection, which confirm our 4 answers. And we see we have our circle that we thought was a circle. This blue one with the 4 leading coefficient is what we call an ellipse. It's like an oval, essentially. So you can have an ellipse intersect a circle and actually hit as many as 4 times. So different type of question. So I want you to try this one on your own, and I'll show you the answer in a second after you pause the video. Try and do it, and then resume the video when you're done. Okay, so if you've finished this one, this is kind of what it'll come out to be. Now, I didn't put my answers down, but we have a parabola and we have a circle. So my x values, I actually found it easier to get the y's first. So those are my 2 y values. And you can actually just go ahead and plug in your y value to solve for x, which is a little bit different. And when you do it one way, you'll get an I root 7, right? Plus and minus, which is interesting. So I would actually want to write that as a coordinate. So I would have, I root 7, and then that's what I did with negative 4, and then negative I root 7. Also negative 4. And then when I plugged in 3 for y, right there, x squared plus 3, I'll just get x equals 0. So that'll be 0, 3. So this is my only real solution. Now, I'd still make sure you mention these. These are definitely solutions. They're just not intersections, right? But they are zeros, right? I can plug in I roots, or not zeros, but they are solutions, I should say. Wondering what that could possibly look like. If you have a parabola and a circle, right, it is possible to hit it once. It's possible to hit it twice, and it's possible to never hit it. But it is possible to hit it once when you have what we call a point of tangency, which happens right there. So That's pretty much it. I do have some partner practice that we would do, in a normal block, but I would definitely encourage you to try, maybe one or two of these if you're not feeling so good about them. Um, Otherwise, I think you guys are good to just start those 3 questions I believe I assigned for the Wednesday work.